Okay, Math 8 students, we are starting Module 5, and this is the notes and video for Lesson 5.1, Writing Linear Equations from Graphs and Situations. And we are going to go ahead and jump right into this. By the end of these, you want to have a good understanding and be able to answer our essential question here of how do you write an equation to model a linear relationship given a graph or a description. So that's what we're trying to do here. That's our objective. So first one we're going to look at here is writing an equation from a graph. So they give us the situation, but they also give us the graph. Let's go ahead and take a look at that. A video club charges a one-time membership fee plus a rental fee, so one-time membership fee plus a rental fee for each DVD borrowed. Use the graph to write an equation in slope-intercept form to represent the amount spent, y. So the amount spent is y. On X number of DVDs. Okay, so slope-intercept form is our y equals mx plus b, where m is our slope and b is our y-intercept. Y is our dependent variable and x is our independent variable, and that's all review there. So just keep that in mind as you go through here. So the first thing that we're going to do is we're going to take a look at the graph and we're going to pick 2 points on the graph. And it doesn't matter which 2 points you pick, just 2 points. So I'm going to go ahead and pick this point right here, which x is 0 and y is 8. And I'm going to go ahead and I want to pick another one that's easy to find. So I'm going to pick this one here that's at a nice intersection point. So it's not kind of in between these ones, like these aren't really at a clear x or y value. And so that is x is 8 and y is, looks like they're counting by 2s, 18. Okay, so I've got my 2 points. And I'm going to find my slope by finding my change in y over my change in x, okay? So you can use that 2-point form, the y2 minus y1 over x2 minus x1, right? And remember, this is our rise over our run. And I'm going to plug those in. So I've got my y2 here, which is 18, minus my y1, which is 8. So 18 minus 8 over my x2, 8, minus my x1, which is 0. So 18 minus 8 is 10. 8 minus 0 is 8. Okay, so I've got 10 over 8, and that's my slope. So if I was going to graph these, I would want to leave this in this fraction form. But since I want to find, this represents the cost for my DVD rentals, I'm going to go ahead and turn this into a value so I know what that represents. And so this would be 1.25. And I know that because 10 divided by 8 gives me 1.25. And this means that that's my rate of change, so that's my cost per DVD rental. Could I have just counted my graph? Yes, I could have just counted my rise and run here. So from this point to this point, I went from 8 to 18. That's a positive 8. And I went from 0, that's a positive 10. 8 to 18 is 10. And then I went from 0 to 8 for my run, and that's a plus 8. So again, that's the plus 10 over plus 8. So that gives me the same slope, right? My rise over run. So now I've got my m. So m equals 1.25. My y-intercept is where my point crosses the y-axis here, or in this case, my initial value, my starting point. So when x is 0, y is 8. So my y-intercept is 8. So now I've got my slope and my y-intercept. Okay, so I just paused that for the bell, so let's see where we're at here. So I've got my slope and my y-intercept, and I'm going to plug those into my slope-intercept form, which is my y equals mx plus b. Got my m, got my b here. So I've got y equals 1.25x plus 8. And what this represents if we go down here and check out these reflect questions here, is that the value of the slope represents our cost per DVD rental. And the y-intercept represents our amount spent for 0 rentals, or our membership fee, right? Because you've got a one-time membership fee, so our membership fee. And this is a one-time cost, right? Or initial value. So that means if we look at this equation here, if I'm going to rent a DVD, it's going to cost me $8 for a membership fee one time, and then $125 per every DVD. And so that's what give me my total cost, right? Say I'm renting 4 DVDs, 8 plus 125 times 4 DVD rentals would give me my total cost. So that's what we're doing here, pulling those equations from graphs. So what I want you to do is I want you to try this one on your own. And so pause the video, work through it, and see if you can get the equation, and then press play and see if you got it correct. So hopefully you paused the video and you worked through this question here. And what I'm going to do is something that I haven't been doing. I'm going to go ahead and write the answer up here, and then I'm going to work through it, okay? So you can just check your answer. If your answer is correct, sweet, you can fast forward to the next example that we're working through. If you didn't get the answer correct, I would continue to watch the video and figure out how that is done. So the solution to this one is y equals negative 2.5x plus 25. So if you got that correct, go ahead and fast forward to where we're doing the next example. If you did not get that correct, go ahead and hang out here, and we're going to work through this together. So we are finding the slope and y-intercept from this graph. Let's read what this graph is showing us. The cash register subtracts $2.50 from a $25 coffee cafe gift card every medium coffee the customer buys. Use the graph to write an equation in slope-intercept form to represent this situation. Okay, so slope-intercept form is our y equals mx plus b, where m is our slope and b is our y-intercept. So slope is our rate of change, y-intercept is our initial value. So we're going to look at this graph, and we're going to find our slope, which is our rate of change. So we're going to pick 2 points. I'm going to pick these points right here because those are really clear, easy points to see. And we're going up by 5 on this. So this value here would be when x is 0, y is 25. And this value right here would be when y is 0, x is 10. So x is 10, y is 0. And then since we read from left to right, these would be my first values, these would be my second values, right? So that's how that works. So my slope is going to be my rise over run, which is my y2 minus y1 over x2 minus x1. So what I've got here is I've got my y2 value right here, which is 0. 0 minus 25 over 10 minus 0. So I've got negative 25 over 10. Now, since we're dealing with money, I'm going to go ahead and put that into slope-intercept form. Or sorry, go ahead and put that into a decimal and figure out what my cost is per coffee, which is essentially what I'm figuring out here. And that is 2.5, negative 2.5, which represents this value here, m equals negative 2.5. That means that every coffee costs $2.50, and that is being deducted from the initial cost or the initial value of the card. So the initial value of the card is what we start out with here. It's on our y-axis, where it crosses the y-axis. So when x is 0, y is 25. So B equals 25. So our equation is y equals negative 2.5x, so $2.50 per each coffee on a $25 coffee card. Now, you could also write this y equals 25 minus 2.5x, saying that you're starting out with a $25 card, and every time you buy a coffee, it is taking $2.50 off that card, because x represents our number of medium coffees and y represents the value remaining on the card. So that could be a little confusing, but this is a real world situation here. You want to determine how much money you have left on your card. You could have also just pulled that information from this situation. Subtracts 250, so that's our negative per card from a $25 card, right? So that's our initial value. So this is our M and B. And that's where we're going next. Okay, so we're going to write an equation from a situation. So this scenario here is giving us the rent charge for a space in an office building, and it's a linear relationship to the size. Let's start over. The rent charge for space in an office building is a linear relationship related to the size of the space rented. Okay, so rent is related to size of the building. Write an equation in slope-intercept form for the rent at West Main Street office rentals. And so we've got this information here. So what we're going to do is we're going to determine our slope and y-intercept from this information. So what we've got here essentially is we've got a dependent variable and an independent variable. The cost depends on the square footage. So these are going to be our x values, and these are going to be our y values. So we're going to find that rate of change with our y2 minus y1 over x2 minus x1. So our second y value here is 1,150 minus our first y value, which is 750. And we're going to put that over our x values. So 900 minus 600. And so what that's saying is that I'm trying to find the difference here. For 600 square feet, it costs 750, and for 900 square feet, it costs 1150. So I should be able to figure out what it costs per square foot in this formula here. And so what does that give me? 1150 minus 750 is 400. And 900 minus 600 is 300. Now that simplifies to 4 over 3, which I could leave in this form, or I could find out what that actually represents. And I'm actually going to leave this in this form because this is going to be a repeating decimal if I turn it into a decimal, because thirds end up being repeating decimals. So this is saying that for every 3 square feet, it's going to cost $4. So that's the rate of change there. Every 3 square feet costs $4. So this is our slope. And then we're going to find our initial fee. So how do we determine that? How do we determine our y-intercept? Well, we have to solve for b. So this is something new. We're going to plug our slope and then an x value and a y value into our equation. So we're going to take this over here. Y equals 4 over 3x plus b. And we are trying to solve for b. So we're going to plug in 2 of these values, and let's just go ahead and pick these 2 here. They're x and y. And plug those into the equation. So y is 750 equals 4 over 3 times 600 plus b. Okay, so now I've got everything and I should be able to solve for b. So 600 times 4 over 3 put 600 over 1. 4 times 6 is 24, so that's going to be 2,400. 3 times 1 is 3, so now I've got 750 equals 2,400 over 3 plus b. I'm going to simplify this down, right? So 24 divided by 3 is 8, so 2,400 divided by 3 is going to be, and I'm going to actually write this over this way. So this equals 750 equals 800 plus b. So do you guys see where those inverse operation practices are coming in now? So I'm going to minus 800 minus 800 to solve for b. So that cancels out, and this is negative 50 equals b. Okay, so I've got b, I've got m. I can make an equation. Why is this negative? What does that represent? Anybody have an idea? Think about it. So if it's negative and that's your initial value, that represents a discount of $50. Okay? So that means that they get a discount of $50 off their rent. So this is the cost per square foot, so no matter what it costs, they're always going to get $50 off their square foot rent for whatever reason, who knows why. So here's the equation. Y equals 4 over 3 x minus 50. Okay? $4 per 3 square feet, and they subtract $50 every rental cost, every month for rent. Okay? Who knows why? It's just what they do. B and slope, y, slope and y-intercept. So now you're going to go ahead and do one on your own. Oh, let's do reflect first. So without graphing, tell whether the graph of this equation rises or falls from left to right. And what does that mean in the context of this question? So rises or falls means is it positive or negative? And it is a positive slope. Which means it's going to rise as you go from left to right. So what does that mean? That means as square footage increases, cost is going to increase. So the more space, the bigger office it is, the more it's going to cost. So as square foot so does cost. Okay. So let's go ahead and you're going to try this one on your own. And what I'm going to do is tell you to pause the video, work through this, and then I'll write the answer up here. And if you didn't get the answer, I want you to watch as we walk through this one. Okay? So pause that video now and work through this. Okay, so hopefully you paused that. And the solution that you should have got should be in slope-intercept form. Y equals 0.5x plus 10. You could also have gotten y equals 1 over 2x plus 10. That would be okay also. So if you didn't get that, go ahead and follow along with me while I work through this question. So we are looking for slope and y-intercept to put into slope-intercept form. Y equals mx plus b. And we have a scenario here where Harry's weekly allowance varies depending on the number of chores he does. He receives $16 in allowance the week he did 12, so 16 and 12. And $14 in allowance the week he did 8. Write an equation for his allowance in slope-intercept form. So we've got dependent and independent variables here again. The amount he makes depends on the number of chores he does. So our dependent variable is our cost, our money, how much he makes, and our independent variable would be the chores. So that means X is chores, and y is total allowance. So we've got 2 points here. We've got 16 and 12, where 12 chores gave him $16, and 14 and 8, where 8 chores gave him $14. So I've got 2 points. And from these 2 points, I can use my y2 minus y1 over x2 minus x1 to get my rate of change, or his number, the amount he earns per chores. So I've got 14 minus 16 over 8 minus 12. So 14 minus 16 is 2, negative 2, and 8 minus 12 is negative 4. And so here's where some of you guys are making a common error. When you have two negatives here, they cancel each other out, and this actually becomes a positive. You could have done this the other way around. You could have gone 16 minus 14 and 12 minus 8. That would be fine too. They both work out, so you have end up with a positive 2 over 4, or 1/2. Since we're talking about money, decimals do make sense here. So this would be 0.5, which means he's making 50 cents per chore. Not very much, but it's still something, right? So our slope is 0.5, which means he's making 50 cents per chore. So we need to determine what his initial value is here. Is he getting some like just base allowance and then he gets extra for the chores he earns? Let's find out. So we've got to do what we did in the previous one, where we've got to plug in our x and y values. So we've got y equals mx plus b, and we have a slope of 0.5, and we're trying to solve for b. So let's go ahead and plug in 12 and 16. You could plug in 8 and 14, both work. So my y value is 16, and my x value is 12, and I'm going to solve for b. So I know that 0.5, or 1/2 of 12, is 6. So now I've got 16 equals 6 plus b. I'm going to rewrite this up here so I've got more room. And using my inverse operations, which we practiced Monday and Tuesday this week, I'm going to solve for b. So it looks like I've got a bunch of, this is another 6 here, but this is the letter b. So minus 6 minus 6, that cancels out. Got 16 minus 6 is 10. So 10 equals b. So he gets $10 no matter how many chores he does. And so that represents my b value. So I've got my intercept, I've got my slope, and that gives me y equals 0.5x plus 10. Harry makes $10. He gets $10 a week for allowance, plus 50 cents per chore he does every week. So when revisiting our essential question, how do you write an equation to model a linear relationship given graph or description? You are going to use pairs of values for input and output to determine the values for the slope m and the y-intercept b in the equation y equals mx plus b. You're going to use pairs of values to determine slope and y-intercept to make an equation of y equals mx plus b. All right, guys, that's it. We'll be working on this lesson in class tomorrow. If you got questions, please bring them. Make sure if you are confused, you are asking questions in class. I will see you guys on the flip side.